Hi, Sam. Yeah, I'm preparing the symbol for the sensor instead of trying to download it from somewhere. I don't know if it's possible. We can check. So I will create the symbol for the device, and the footprint is pretty standard. It will be part of the standard KiCad library. It's a QFN 3x3 millimeters. Yeah, I think it's too new to be available in internet databases. So yes, new symbol. Hi, Robert. Thank you. Thank you. That's an excellent idea. I will let you know next time. It will be in 3 weeks because next 2 weeks I will be out of the office. Thank you. Thank you. And we will get in touch and prepare some cooperation. Bye. Good morning. Let me check. No, the funny is that I can't copy the address from the comment. Uh-huh. Okay. Do you think it's useful and suitable for an actual work or just a toy project? Please let me know. Cheers, bye. Yeah, you can see, or you could see that there is a recommended exposed pad, or no, the physical exposed pad is 1.7 millimeter square, but I'm using this standard library footprint with 1.65 exposed pad. They recommend, I can see that they recommend the placing vias, so probably I will change the other one. And the recommended size of the exposed pad is 1.8. Okay, so probably I will create a variant of this, because this is too different from the standard one. So with vias 1.8, they say. We have some questions. Hi, Chatura, Fernando. Yes, sometimes. Yeah, the colors in step files are always trouble. I don't think I can give you a piece of advice to that. What I can say that sometimes KiCad refuses to generate the step file. Let me show you. When you're generating the step file, there is a board outline chaining tolerance. I don't know what does it mean, but sometimes it helps to change it to standard from tight. Sometimes it helps to, for instance, export only some components. You can select which one do you want to export, which ones. I don't recommend to export tracks and vias because then the step file is too big. Even the pads are not needed. I think the board, the flat board with the components is enough. So basically, it didn't happen that I wasn't able to export the step file. It happened that I had some troubles exporting it, but I always managed to do that. So I believe you will do as well. So back to symbol. No, back to footprint. We said that we want to create a customize. Where are you? I'm looking for the footprint here. Footprint editor. 1.8 times 1.8 with vias. It seems, yeah, that's the one I just exported. So this exposed pad will be 1.8, 1.8. But I think they used smaller pads. So let's check. C1 is the pitch between the pads on opposite sides of the package. C1 is 3 millimeters. So the center of the pad will be 1.5, and the width of the pad is epsilon1. Y1 is 0.8. Okay, let's check it. So yeah, C here is 1.45. This dimension is, or position is correct because it's given by the pitch, and the pad size is as well what I said, 0.8. Yes, so 0.05 of the millimeter to the side. So there are two options. There are many options. I can edit each pad individually, which is not very good job. I can delete all the pads and use the create array from selection. So I will export the, not export, I will copy or duplicate the pads. Or if, yeah, I think that's the best way because we have to change the position and the size. So this way I will delete this, use it in a correct position. And now when the pad is selected, I press Command T, which is create array from selection. Let me show you. Here is the window for the tool. Horizontal count will be 1, vertical will be 5. Horizontal spacing 0.4, which is the pitch, not on this row or column of the pads, but the bottom and upper edge. And source will be, like the source item will be the first one, and numbering will be 1 with incremental 1. Okay, the same with these pads. Yeah, I think it's the best or the fastest way. You just take care of the pin numbering and these grid array size. So now it will be 5, 1. Yeah, now again, edit the first pad, size and position, create array. This will be horizontal count will be 1, vertical 5, but take care, horizontal space is minus 0.4 because we are going from the bottom up, and numbering start will be 11. Nice, and the last one is here, this one, 16. So edit the 16, 1.5, 0.8, create array from this. 5, 1, vertical. I can keep it, but Anyway, -4, numbering is 16. Perfect. So this is our these are our pads. I noticed that they use like chamfered exposed pad. Let's do that. So here is the chamfered rectangle setup, and you can choose which corner will be chamfered, and the dimension of the chamfering is the chamfer is probably not here. So I think slightly less than this. It looks like the corner of the chamfer is aligned with the bottom right corner of the first pad. And we are here. Yeah, it seems like 10%. Exactly. This is our exposed pad. And what size of the vias is recommended here? I definitely will not below 0.25. They say this dimension is this 0.3. Fine, that's pretty comfortable size. Take care about these vias in exposed pad. Sometimes the standard KiCad library uses 0.2, which is too low, and if you keep it, it means that usually this exposed pad vias are the smallest one on the design, which means that these pads will push or put your design to the higher expensive area or manufacturing class. So take care about these. And I usually edit the size of the silk screen label. It's not very important. It's not important because I can use the tool for global changing sizes of these reference designators, but yeah, anyway, I'm doing it all the time. And when you can see, this is the standard KiCad library. All 3 corners are like full corners, and the pin number 1, there is a missing line here. I don't like it much because sometimes manufacturing people are confused with this. So let me correct it. Yeah, there is some range 1.16, 61, 61, 16, and the thickness is 0.12. 12, and now I want to create a triangle, which is, I think, pretty good mark of the pin 1, better than the missing element of this corner. So let's check the comments. Yes, definitely. I will take a look at it. Thank you for the tip. Sometimes it can be a nice toy for like KiCad live stream or something like this. Thank you, Sam. And I can see, yeah. Thank you. Probably a similar symbol as I created. So yeah, thank you for that. I used to create my own symbols when the number of pins is like moderate, 20 is not much, and of course I can make a mistake, but I like my shape of the symbols, like all inputs on the left edge, all outputs on the right edge. But yeah, there are exceptions like this. I placed the output WU on the left edge. But anyway, thank you. So let's check the step file for the model. Here it is. Nice one, fitting one. Okay, so here is our footprint. So let's finish the symbol. Let's finish the symbol. It was this one, yes. Okay, our symbol is done. Every time I'm checking the pin numbering here in the pin table, so you can see that there is a mistake. There is a not connected pin number 1, which doubles the reset pin number 1. There is my mistake, so I need to correct it. Yeah, I remember. I duplicated the pin 14, but I didn't edit the pin number. I think it was 20. Let's check the datasheet. It was 16, not 16. 16. Okay, so it was a typo probably. Now 16. Let's check again the pin table. Looks good. Okay, and when I call the symbol checker, it looks fine. Okay, so this circuit has two input elements. It's a like capacitive sensing method. Let me find it here. Capacitive detection method, which using this shape of sensor, like quite useful shape, but the second element mirroring the sensor is grounded, and there is, it means that a single-ended capacitive sensor element, like when you are using the touch sensing plates for fingers. And there is the second variant of sensing. It's called conductive sensor design, which uses 2 electrodes. None of them is grounded, and the first electrode is connected to the SCON1 and the second SCON2. So this is the single-ended input, and this is the conductive mode. I don't know which. Yeah, my initial plan was to design the eval board with both sensing elements, but I'm not sure if this the capacitive sensing traces are too sensitive. Yeah, we can place a jumper or 0.0 ohm resistor in the trace of the capacitive sensing. Basically both elements would be similar or the same, but the other I'm sorry, the other electrode will be grounded in the single-ended variant. But I'm not sure if it works. I quickly checked the official evaluation board, which uses like both elements. You can see here is the capacitive sensor, so one electrode is grounded, and this is the conductive sensor, and they use like both. And when you plug the adapter here, it's like capacitive sensor, and then you plug the other one, it's conductive sensor. I don't know if it works with both modules plugged. This is the marketing picture only. We can use similar way. Probably I think it can be interesting to place the capacitive sensor on the like top side of the PCB and the conductive on the bottom side, and to use the jumper on one side or the component side to select which one will be used. It means there will be 3 jumpers connecting the capacitive trace for both elements and grounding the second electrode of the sensor. Yeah, they are using the potentiometer for the threshold setting. I will probably use a trimmer or potentiometer as well, like with the handle. I don't know. Yeah, the sensor looks like According to the datasheet, it looks like it can work pretty reliably, detecting the various types of liquids. I'm not experienced with this type of devices, so I want to design an evaluation board for that. And yeah, definitely I want that the board is working when it's manufactured, but yeah, it can happen that it will won't work because there will be some interference between the inputs. I will use the serial resistors anyway because they are quite requested by the datasheet. So in any case, I can isolate the track completely by unsoldering the resistor. So I think it will work. And when we check the data sheet, there are very simple. Here is the capacitive sensing. Like here is the sleep period. I don't know how it works. I didn't study this part of the data sheet. This is the potentiometer for the threshold. This is the heartbeat signal, the output signal, like this one, heartbeat, like periodic signal, each like 300 milliseconds. Here is the output. The output is digital as well. I think they modulated the duty cycle, probably. I don't know. Anyway, this is the error state, so not the best waveform to study. Extended output. Yeah, there are UART outputs, like digital outputs. Yeah, and here is the there are like spots when the liquid is like sampled, liquid detection is sampled. So this is the output pin. So check for liquid detected, no liquid detected, no liquid detected. Okay, I understand now. So this is really the digital output. When you set the threshold and the detection of the liquid is over the threshold, the output is active, like the liquid is detected. When it's below the threshold, it's not undetected. So you have to play with the threshold for various liquids like water, oil, I don't know what else. And the sleep period probably set this time between the samplers. Great, can work. Can work, and yeah, nothing like super complex, but yeah, it can work. So let's continue with the schematic. I think I will be happy if today I will finish the schematic, and next time, sorry, I will create the PCB layout. So let's continue with the schematic. We have the symbol. Power supply is, I think, 1.82555 as we mark. No, I didn't mark here, but I have to. VDD 1.825.5. I will check it. Let me check it. The beginning here is the 24. Yes. 24. Okay. So schematic update. Yes. So I will do 3.3. Power supply, I will most likely use some kind of Arduino board. Today I played with the new Arduino Nano Meter. Frankly, I don't know if it's too new, but it works pretty well. And even for non-programmers, I was able, when following the example, to create a 𝗏𝗏𝗀𝗃 device, which I commissioned to my Apple HomePod, and I can use the iPhone to control the light bulb color. Yeah, pretty easy example, but the library by Silicon Labs contains like 20 or 30 different examples, like light bulbs, remote switch, humidity detector, liquid detector, yeah, anything for the home, smart home. So I think there is a big potential for that. What's like disadvantage is that most likely you need certification for this, for the Matter, and when the device is compatible with HomePod, you need some certification, you need some unique identifiers. It's like USB, or not USB, the Bluetooth, I mean. So you need some money, yeah, to register your device and to get the unique numbers for your company, for your vendor ID, product ID, similar to USB, similar to Bluetooth. Back to work. So they say that, yeah, there is a reset, very simple reset. Each of these signals have a 1K resistor in series because they connect them directly to ground or the VDD, no problem. So I can say that UART enable is disabled here by grounding, and this is enabled. Yeah, I don't know why, because they don't use the TX and RX anyway. But there will be a jumper for that. So jumper for op mode. Op mode means capacitive, yes, or conductive. Sleeper, there is not sleeper, the sleep period, there is like dip switch or something. Yeah, frankly, I don't know. I want to keep the price of the eval board as low as possible, so I will probably use a dual row header and with 10 positions, and you can, by placing one resistor, you can connect the sleep period to the input pin, like the voltage divider to the input pin. Yeah, I think that's the best way. And the trimmer, yeah, the most comfortable way would be to use the potentiometer with handle, because my plan is to merge the PCB into some cup with water or with some liquid, and like 10 centimeter height of the PCB, like 10 centimeter, and to to set the threshold from outside, and to keep the electronics naturally out of the water, out of the liquid. Yeah, so it means we can continue with this, but I think I need a little short pause, so give me a second, please. I will be back in a minute. Yeah, I'm here. I forgot that I could use this rest period for announcing that my new course is online on 𝗲𝗀𝗀. So today the course was released. The tutorial was released, the course. So yeah, you can check. You can design this kind of device. This is the carrier board for note cards. There is the Raspberry Pi MCU 𝗲𝗲𝗀𝗚 dual-core MCU, 4 digital outputs, 4 analog inputs, power supply 3.3, power supply 3.8 for the modems on the note cards. It supports various type of note cards. There is a USB Type-C for the note card, SIM card slot connector for the note card. Here is the Type-C for the MCU, so you can connect the Arduino. And it's like embedded platform. There are 3 LEDs, boot, select, and reset. Yeah, everything that you need. Comfortable terminal block, fuse. KiCad for makers. Yeah, I spent tens of hours doing it, and now you can enroll the course for, I think, pretty good price. So highly recommend it. Let's get back to work. So reset, they say. Okay, I will copy it because why not? One exception is that there is pretty few space on the schematic between the pins, so I will use the designator like on the side of the resistor, and the reset will be like a little bit farther from the symbol. 1K resistors as well, like here. Value and the designator. Yeah, like this. I can copy it. Sleeper period as well, threshold as well, config enable as well, syslog as well, UART as well, and I think why not here? Hi Ivan, yes, the course, the tutorial, the course was released today. So KiCad for makers, 𝗲𝗀𝗀, and yeah, you can enroll now. The tutorial is ready, it's available. Thank you for the question. So yeah, I placed the 1K serial resistors for TX and RX as well. Nothing against that, and as well 1K resistors to the wake up, output, and heartbeat. Now let's finish the reset. 10K pull up. The 10 nanofarads capacitor here, like this. For 70 as well. Again, and now there is a button. I don't know what type I will use. Probably this one, the favorite one by many makers. It's not the best button because the like, I don't know how to say English. Like when you press the button, there is like short way when the button operates, but yeah, it works reliably and it's pretty cheap. Here I will create some labels as well as they. 𝗁𝗶𝗴, 𝗏𝗏𝗃𝗏. So for the enable syslog tx rx UART enable. Now the outputs wake up, out, and the heartbeat. So now they are using. So I said that there are serial resistors on the conductive sensor, but not. They are not. I think, yeah, I can study this. I can study this application node as I already did, and there are probably some recommended values. I think it's like between 1 and 100, something like this. I think I used for 70 as well. Yeah, it's a component to play with during the testing, but probably this is why they don't mention the exact value, because yeah, this is the subject of configuration. Yeah, I will place one for 70 as well here, and we will see. And the pull-ups are unknown as well, which is probably we should study the evaluation board, because schematic 10K pull-ups and 10K the serial resistors. Okay. 10K. Yeah, I should place the pull-ups as well anyway. Yeah, but I said we need, as I said, we need the jumpers. So probably the jumper will be in here. Here. And the second one will be here. The third one will be here. I hope it will work. And on the opposite side, there will be the pull-ups. No. There should be to the IC side, because even without the, definitely. And I'm not sure if some ESD components should be there. On the evaluation kit there are not, but probably I will place there some of them. Okay, so I will make some space here like this. Here will be two pull-ups like this, exactly. Yes, so even without the jumper, the inputs are defined. Yes, here is the sleeper period. They use only 4 positions, not 10 as in the datasheet, so probably we can follow this strategy to use less jumpers. I like that more than the 10. But yeah, I don't know. We can use 10 of them. Why not? Why not? So threshold is the potentiometer. This is the jumper array. This is the jumper, like 3-position jumper op mode. Yes, so let's start with the op mode. Yes. Okay. 3-position jumper for the op mode. One will be grounded. The second side will be connected to the 3.3. This is the op mode. What else is here? Config enable. Config enable is either yeah, always VDD, but we have to check what this input does. Config enable, where are you? Here. Enhanced configuration mode enable. Okay. Okay. What does it mean? Enhanced. Usage of enhanced configuration mode. The following table shows the correspondence. Okay. Okay. When it comes to setting parameter. Flexibility. Okay. Okay. I will use the 3-position jumper as well, because I don't want to be limited with the fixed value in the future. So what else? Sleeper period, yeah. So it's up to us what size of the voltage divider we will use. There is like 4-position, and we can use 10-position. But even the 4-position one, I can see that there is a 2 seconds, 16 seconds, and 128 seconds. So quite a big range. Okay. I need to check the values because the 300K is not standard value in my kit of resistors. So yeah, and it looks like there are tens. Sleeper period. Let's check it. Let's check it. It's not so obvious. Sleep period. Okay. Okay, so ideal value are ninths of the power of the voltage, of the supply voltage. Okay, so it means the proposed voltage divider the output of this voltage divider when placed, here is the ground, yes, here is the 10K slash 1 mega ohm, which is 1/10. No, there is only 9 positions. There are only 9 positions. So 9 resistors only. Okay. Yeah, and this is why they use 300K, because it works with the ratio of 9. Yeah. Yes. The sum of the resistors is 900. No, 900. Yes, 900. Yes, and they select 2 out of 10, or 2 over 10, 4 over 9, or 8 over 9. Okay. Okay, there is some. Okay. So the most useful, most straightforward way is to use the 100K resistors and use only a few of them, like only a few positions. This will be my way, I think. 10K. Yes, we need. We need 9 of them. No, here 3, and we need 3 such combinations here. Do they use the 0? No. Yeah, they do. They have 1K in here, but probably it doesn't make much difference. So here can be one, and yes, and the other one is here with the 1K. I will place the 1K here because I don't want to damage the IC by collecting directly the 1K. I don't think that it will make any harm, but when they use it, I can anyway. Okay, so here is the monsters. Okay, and we will use like header 2 times 4, yes, and this will be the ground. This one, this one, and this one. I will not place the ESD diode because this setup will be probably done when the device is powered down. Here is the sleeper period. Okay, they use like 1 nanofarad here, so let's do that. Thank you, Dimitros. So sleeper period, operation mode, config enable. Now threshold, we will use the potentiometer. Config enable, this is already placed. syslog, what does it mean? Syslog, what does it do? Let's check. Syslog, system log enable. I don't know. System syslog. Disabled, enabled. Okay, we will use this reposition jumper as well. It will be like jumper over jumper, but yeah. To have some flexibility in setup, we need to do that. UART enable. Yeah, this reposition jumper as well. Okay, so threshold. What else? These are only outputs for the microcontroller. Yeah, I will place the LEDs as well on these outputs. Here will be our like electrodes for. I will use some polygons on the PCB, and here will be connector con 1, okay, and con 2, okay. So the potentiometer, I don't have potentiometer in my library. Or I do. Okay, 100K. What's this? Yeah, this is the small one, yeah. No, such a big one. So this is the smaller one, these are smaller ones. I don't know what this is. Yeah, this is the nice one. I like that. This is almost the exact as they used. Yeah. Yeah. Let's check the availability and price. We need probably 100K. Normally stock available to order. Okay. So let's find an alternative. Probably we don't need the same value. Let's check the other values. Yeah, 1K is pretty available, 5K as well, 10K not. And the price is crazy high. I don't want it. I don't like it. This is the SMD, the trimmer. Yes. Yes. Okay, so let's find some. This is 10K, but anyway, we need the PCB pins, linear, active, and yeah, let's find. So in stock, resistance, okay, 1K, 100K. Let's see. This is a cute one. Yeah, that's and for such a low price. Yeah, I like that. And the same Sky or formerly CUI devices provide us with nice models. So I will use this. What's the difference between the 120 and 115? Length of the actuator. Yeah, 20 and 15 millimeter. Yes. The price is the same, but the more available are 20 millimeter one. So let's do that. Here is the model. Okay, so I have to create a footprint, and the model is beautiful. Yeah, perfect. Okay, so this can be our piece, but we will use this part number and as an OC. What? Yeah, that's okay. That's not a clever way, because Chinese manufacturers have 1 million of pin compatible ones, but to save some time I will use the same part number, and this is 100K one turn, and the power the maximal power is 50 milliwatts, and it's a really small one. Here is the data sheet, and we can be lucky. Sometimes even KiCad contains pretty standard, or not pretty standard, but some PT01. Probably not. So we have to create the new footprint. So here's KiCad pool. Nice. So I have to add the project specific library in my downloads KiCad pool directory here. This is the trimmer. Yes, looking good. I will check the diameter of holes according to the data sheet, but it looks good. So I will save it into my library. So let's check the data sheet. Same Sky. Recommended here. And pattern. Definitely not achievable like these square holes. So anyway, 5 millimeters is the pitch of the, yes, that's correct. 7 is the, yes, the distance between this and this, and the 1 millimeter hole is the, yeah, the footprint is correct. And now I'm awaiting that the KiCad will crash, because sometimes, well, pretty frequently when I adding the step file for my new trimmers, for my new footprints, it crashes. So there is a trim, RST, RST, RST. Okay, so we need to reopen the editor because it doesn't see the, it can't see the new models, new files. Trim. Okay, there is no such a file. So I probably copied it and differed in the wrong direction. Aha, okay, there is no trim. The trim underscore is the name of the footprint, but the 3D model is only PT1.1101. This is, when I save, no, doesn't crash. We are lucky. And I think the model needs fine-tuning like this. Yes, good. Okay, so we have footprint for our trimmer. Nice looking trimmer, PT01. Yes, this one. And we can place it here, but we have to remove this because our trimmer doesn't have this pad. And yeah, most important thing, we have to check the pin numbers. 1.123 and 2 is the 𝗲𝘀𝗶𝗴. Let's check it. 2 is 𝗲𝘶𝗴, so it's correct. And according to the datasheet, there is 1 nanofarad capacitor, and they use, yes, 1 nanofarad. So the same as here, like here, probably like this. And this is the sleep config. No sleep config. This is, yeah, I'm checking the different one. I'm checking wake up. I'm checking wake up. Where are you, wake up? Here, 1K and okay. 1K and 1 nano. Okay, and here is the no wake up threshold. Yes, threshold. Wake up. How they? Yeah, these are inputs for the MCU. So we will need 3.3 ground. Wake up out HB takes RX. Oh, again, see ground 3.5. 7. ground. And here will be 1, 2, 3, TX and RX. And here's the diodes. Because this will be, no, this will be an exposed connector. We have 5 pins, yes. Yes, we do. Thick. Okay. So we have the systemic connector. Here we need mounting holes with pads. Grounded. And this will be the last components. No, logo of many devices needs to be added here. So yes, this will be polygons. The capacitor and con1, con2 will be polygons on PCB. Sleeper. Okay, I will annotate and call the DRC. No, DRC, ERC. Okay. Let's check it for some missing signals. Input. Yeah, cap. Okay, it will be polygons. Okay, so 3.3 and ground needs some power flag. It's the usual annoying. For instance, here. So annotation and here. Okay, just 3 labels are not connected anywhere. Okay, these signals will be connected to polygons, so no problem. So I can see that we are finished for today. The schematic is ready, and next time we will work on the PCB layout. So thank you for watching, thank you for being here, and let me conclude this with my favorite tutorial. Bye bye.